Hello, today we'll look at some examples of solving right triangles. Our first one, we'll have a right triangle, triangle ABC, and we're just giving the length of two sides. So we have side A and we have side C. And side C, as you can see, is directly across from my right angle, so it is known as my hypotenuse. So it is my longest side. So just for our reference, I'm going to write up here our trig functions, which are sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. Okay, so the first thing I have side A, and A is always across from the angle A, and I have the hypotenuse. So I can find side B. So let's find side B first. And I can use a number of things, but I choose to use Pythagorean theorem. And Pythagorean theorem says that we have a leg squared plus a leg squared is equal to the hypotenuse squared. Or, as some of you already know and are probably more familiar with the formula, a squared plus b squared equals c squared. And notice my triangle has those same letter naming. So we'll plug in what we have. Have 11 plus 47 squared. That's my A. I'm looking for B squared. And I need to, and it's going to be equal to 27 plus 82 squared. So I get 131 plus, 141.56 plus B squared is equal to 773.95. I'm going to subtract this 131 from both sides, and I get B squared is equal to 642.39. I'm not looking for B squared though, I'm looking for B, so I'm going to take the square root of both sides. And I get B is equal to 25.35. I rounded it up to 35 centimeters. Alright, so now we need to find our angles. I'm going to find angle A, so I'm going to look at it from angle A. So if I look at it from angle A, I have the opposite side and my hypotenuse. Well, the one that deals with opposite and hypotenuse would be sine. So I'm going to do sine of A, and I'm just plugging things into my formula, equals my opposite side, which is the 11.47, over my hypotenuse, which is 27.82. So I'm going to put this in my calculator, making sure that my calculator is in degrees because I want to find the degree value. So sine inverse of 1147 over 27.82. And I get A is equal to 24.35 degrees. So now it should be easy to find B because I have two angles and we know that the sum of the interior angles for a triangle is always equal to 180. So if I add my 90 plus 24.35 and subtract 180, I should get side B. So that's 90 plus 24.35 minus 180 gives me 65.65. So I'll write it up here because I ran out of space. My angle B is equal to 65.65 degrees. All right, let's do another example. So we're going to solve this right triangle. As a rule of thumb, I think it's important to draw it. So let's draw our right triangle. And we're going to use the exact same naming conventions that are used normally. So we'll say our 90-degree angle, which is angle C, and our side C, which is directly across, so our hypotenuse is 17.4 feet. And I only know this because of the example that we just did. Otherwise, they would have to let us know that C is the hypotenuse. And A is 28 degrees. I'm going to leave off my zeros. So I can easily find B, right? So I know that I have the interior angles of my triangle is always equal to 180, and I know that this angle is 90 and this angle is 28. So 90 plus 28 minus 180 gives me 62. So angle B is equal to 62 degrees. Okay, and now I can also find, so again using the same trig functions, I know that angle A, I know the opposite, and I have the hypotenuse, so that means that I can find this side over here, which we'll label as A. So I have sine of A, which is 28. So let me actually put 28. Plug in what I have is equal to the opposite, which is my A over my hypotenuse, which is 17.4. I'll leave off the dimensions. We know is feet though. So when I solve this, I'm going to multiply both sides by 17.4. Sorry, I ran out of space over here. So 17.4 times sine 28 gives me my A. So when I plug that in my calculator, making sure my calculator of course is in degrees, I get A is equal to 8.2 feet. Alright, so now I just need to find side B, and I can use Pythagorean theorem, or I can use one of my trig functions. I should get the exact same answer no matter which one I use. I think I would like to use my trig functions. So I will use, we know if I want to find this side here, hypotenuse, and adjacent, that would be cosine. So just switching it up, doing a little something different. I can do it in multiple ways, right? I can use the Pythagorean theorem. I can use my trig functions. So I'm choosing to use my trig function. So I'm looking for side B. So this is cosine of 28 is equal to the adjacent, which is my side B, over my hypotenuse, which is 17.4. Again, I will multiply both sides by 17.4 to get my B by itself. And so I get B is equal to 17.4 times cosine 28. And I get 15.4 feet. Alright, so now let's talk about angles of elevation and angles of depression. Alright, so when I'm doing applied trigonometry problems, it's always important to draw a sketch, just like we did for one of the examples we just had with no sketch. We're going to use those sketches to come up with the equations, and then we'll solve the equations. Alright, so we have the length of a shadow of a tree is 22.02 of a tree 22.02 meters tall is 28.34 meters. I don't know why that tongue twists me so much. Find the angle of elevation of the sun. So I'm going to draw a tree. So this is my tree. Okay, and we know that this tree is 22.02 0.02 meters. This tree has a shadow, and the shadow is 28.34 meters, and the angle of elevation to the sun is like so. So I'm looking for this angle. So using my trig functions again, let's look at what we have. So in reference to this angle, I have the adjacent side and the opposite side. So that's tangent. So we'll say tangent, my angle theta, we don't know what it is equal to my opposite, which is 22.02 meters. We'll leave the dimensions off, over 28.34 meters. And so I have tangent inverse, and I can put this in my calculator. 22.02 divided by 28.34 and gives me my angle is equal to 37.85. Alright, let's do one more. Nope, that's it. Well, I hope that this helps.